So the question related to the label, A is representing a solvent from. Another question. Another question. Paper chromatography is used to determine the RF value of 4 different food colorings. So there are 4 different food colorings. Which food coloring has a RF value of 0.6? The formula to calculate the RF value is the distance moved by a spot from the origin divided by distance moved by solvent front from origin. That's a formula to calculate the RF value. So which food coloring has a RF value of 0.6? A, B, C or D? So the correct answer for this one, that is C. Why C is the right answer? Because the distance moved by the spot, and it's not like we take the starting point or ending point, we take a middle, the center of the spot, to a distance moved by the solvent front. So this is 15 and the solvent front 25, so 15 divided by 25, that is equals to 0.6, so it matches with C. The chromatogram for unknown dye is shown. What is the RF value of the dye? The distance moved by the spot divided by distance moved by solvent from origin. Both distances are taken from origin. So what is the right answer for this? Yeah, that's right. C is the correct answer, because the distance moved by the spot from origin, that is 9, and the distance moved by solvent from origin, that is 12. So we take both distances from origin, so 9 by 12 is 0.75. So C is the right answer for this question. Another question. Chromatography is used to separate and identify the components in both colored and colorless mixture. So it can be used to separate the component in colored and colorless substances. For colorless mixture, the chromatogram has to be treated with another chemical. What is the name of this type of chemical? What we call coloring agent, display agent, finding agent, locating agent. So the substance which make the colorless substance visible, that we call as a locating agent. So D is the right answer for this question. This is a specific terminology used for making it visible. The chromatogram of substance X is shown. This time, instead of mentioning the lengths, they mention in alphabets, like they mention the length W, like it means the W is starting from the level of the solvent till the last point. X is from the origin till the solvent. Y is from the origin till the spot. And Z is from the solvent start till the spot. Like instead of mentioning the length, they use these variables, alphabets. So how is the RF value of a substance S is calculated? The formula is distance moved by the spot divide from origin divided by distance moved by the solvent front from origin. So the right answer for this question, which is y divided by x, because distance moved by spot is y and distance moved by the solvent front is x. So the correct answer is C. Is it clear to everyone? So instead of mentioning the numbers here, like sometimes they mention the number, but sometimes they mention the variable letters. In this question, the chromatography is done on a mixture containing a drug. The drug has a RF value of 0.66. The diagram is not drawn to scale, like it does not mean like what is shown 15 centimeter is 15. Which spot on the chromatogram represent a drug? Means which spot is having the RF value of 0.66. The formula for RF value is the distance moved by spot divided by distance moved by solvent from origin. Which spot is having the RF value of 0.66? RF value. This is a baseline or origin, you can see. This is a baseline or origin. So from origin, we calculate a distance. Like example, if we calculate for A, yeah, that's the right, B is the right answer, that's true. But how we calculate this? For example, if we want to calculate the RF value for A, the distance moved by A from the origin, from the baseline, so the distance moved by A is 12. So this will be 12 divided by distance moved by the solvent. So this is the solvent front and it moved 15 centimeters. So 12 divided by 15. So what is 12 divided by 15? That is equals to 0.8. So RF value for A is 0.8. The formula to calculate the RF value is the distance moved by the spot divided by distance moved by the solvent. I write in short here. So for A, spot A moved 12 centimeter and the solvent moved 15 centimeter. So 12 divided by 15 is 0.8. What about B? The distance moved by B from origin. So distance moved by B is 9.9. Sorry. 9.9 divided by 15. So 9.9 divided by 50. What is the answer for RF value for B? That is 0.66. And for C, when you find the RF value, the distance moved by the spot, that is 0.66 from origin divided by distance moved by the solvent, that is 15. So 0.66 divided by 15, that's 0.04. And for D, the RF value, we can, because the spot does not move at all, so D is having RF value of 0, because it does not rise or move. Is it clear? Why B is the right answer? So whenever you calculate the RF value, you take a distance moved by the spot divided by distance moved by the solvent. What could be the right answer here? Amino acids are colorless acids, and it is separated by using a chromatography. The solvent used is propanol. The solvent, the liquid which we are using in case of amino acids, that liquid is propanol. The chromatogram is sprayed with a locating agent. So because amino acids are colorless, so we use a locating agent to make them visible. Which row describe the purpose of propanol and locating agent? What is the purpose of propanol and what is the purpose of locating agent? So correct answer for this one is B. And why B is the right answer? Because what is the purpose of this is a chromatogram. You draw the origin with pencil. You use propanol as as a solvent. We use a propanol. So when this chromatogram will absorb propanol, the propanol will rise, and as the propanol will rise, the amino acids will also move up with the on the chromatogram or chromatography paper. And what is the purpose of the locating agent? When we spray this by a locating agent, this locating agent make the spots visible. So the purpose of propanol to move the amino acid up the chromatographic paper, and the purpose of locating agent is to make the individual amino acids visible. So B is the right answer. Is it clear? Now in this case, a sample of a green food coloring was separated into its component and the color using a paper chromatography. The results are obtained as shown. What is the RF value of the blue spot? So how you work out the RF value? First thing, two of the answers are totally wrong because I told RF value cannot be more than 1. So C and D are totally wrong. Now in this case, as they did not mention or they did not give you the scale, so what you will do, you will measure, you will place your ruler, like right now even you can use your computer screen, place your ruler on the screen and measure this distance, and place a ruler on the screen and measure this distance. So according to your screen, you will measure these distances and divide the value, so you will get the right answer. Like example, if this was 4 point, okay, this is 4 centimeter, and what about this one, the solvent one? You're talking about the spot position, that's 4 centimeter you measure, and what about the solvent? The solvent came 4 centimeter. Okay. And what about the spot for you? Almost 2. Okay, you can take 2. Example, you got it 2. So what is the RF value? Distance moved by spot divided by distance moved by solvent front. 2 divided by 4, so it is 0.5. So 0.5 is approximately, it is same as 0.45. So A is the right answer. So sometime the numbers are not given or shown on the screen. So you have to use your ruler and measure the distance, but always measure from center of the spot to the baseline. Is it clear? And there is also another simple technique which you can also work out. Look, if the spot is below the halfway, like if the spot is less than the halfway, the RF value will be 0.5, like it will be less than 0.5. If the spot is above the halfway, means the RF value will be more than 0.5. So when you check the like halfway, when you check this halfway, the spot is approximately at the halfway. So it cannot be 0.9, it will be in the range of 0.5. This is a short way to get the answer, but you can also use your measurement and find the final answer. Is it clear to everyone? Now, this is a structure question, and most of these questions are from paper 6, alternative to practical, in which you have to either plan an experiment or you have to write an experiment. How we'll carry out this? The question is, the label on the bottle of orange drink stated that it contained no artificial colorings, means there is no artificial color present in this orange drink. A scientist thought that the orange color in the drink was a mixture of two artificial colors, sunset yellow, which is having a colors having numbers. You can find this color codes. So E110 is for sunset yellow, and Elora red, it is E129. So scientists believe that the food orange drink having two artificial coloring such as sunset yellow and Elora red. What you have to do, you have to plan an investigation to show the orange color in the drink did not contain these two artificial colors. So we have to plan an experiment and we want to show that there is no artificial color present such as sunset yellow or Elora red. You are provided with a sample of E110 and E129 and the orange color from the drink. You're also provided with common lab apparatus, like we have the lab apparatus as well. You may draw a diagram to help your answer. So when they mention you may draw, it is better you should draw, so that if you miss any point in your explanation, you will get the marks. Now first, what we do, how we carry out this experiment. So first we will use chromatography technique to identify the colors. That is one thing. Then how we carry out this technique, what we will do, we will draw the origin or baseline with pencil. So what we did, because we are doing a chromatographic, and it's better you draw at the same time. So this is a chromatogram. We drew the origin with pencil. Then after drawing the origin with pencil, we will place the orange ring E110, which is sunset yellow, and E129. These are the color numbers, E129 on the origin. Yes, the chromatography works with juices as well. So place orange ring E110 and E129 on the chromatogram. So what we did, like example, this is orange drink. I'm writing orange drink as O and D, means orange drink. And then we took E110 and then we took E129 and we place all of them on the origin. Then after placing all of them on the origin, because the food colors are mostly water soluble, so we can use a suitable solvent use water as a suitable solvent. So we select water here as a suitable solvent. What is E110 and 129? These are the numbers given for the color. Different food colors have different number, like sunset yellow and Allura red. These are the food colors, so they have their numbers. So food colors are not only represented by their names, they are also represented by the number. Like when you buy any what you call, like example, say jelly is having different colors, so you can see on the ingredient it is mentioned that which color is used. So instead of writing the name of the color, they mention E110, E115, E125 is used. So we use a suitable solvent. Example, we use a water as a suitable solvent. As they did not mention it is insoluble in water, so you can mention water as a suitable solvent. Then we will allow the solvent to rise on chromatogram. Then we will compare, just a minute Abdullah, I will take your question. Then we'll compare the height rise by orange drink E110 and E129. If they rise to different height, compared to orange drink, so the drink does not contain E110 and E129. So when we use this water as the solvent rises, the spots will also rise. Like example, this is a spot of the orange drink, but spot for E110, which is sunset yellow, it was here, and spot for Allura red, that is at this position. So we can see that orange drink is not, the spot of orange ring does not matches with E110 or E129. So it means it does not contain these artificial colors. Yes, Abdullah Sarfraz, what's your question?
So using different solvents will affect the distance traveled.
Yeah, using different solvent will affect the distance travel. If they did not, normally we use water as a solvent, but if it is not insoluble in water, you can mention alcohol. So better just remember two names. Sometime in the question they mention it is not water soluble, so you will mention alcohol in that case. And using a different solvent, the height to which the spot rises may change, but it will not, if it is not the same substance, it will not level up. Is it clear? This experiment, it's of 6 marks. Is it clear to everyone? So basically you should be able to plan experiments. Similar type of questions are there, not the exact same, but similar questions are there. Sometime they may ask how you can find the number of substance present in a food color. So you can just modify the experiment. uh, how we will know that they really does not contain. So how we know they really do not contain E110 and E129 is by measuring the height of the spot. As you can see, E110 does not level up with orange drink. E129 does not level up with orange drink. So if it does not level up with orange drink, it means it does not contain orange drink. Means they are not present in the orange drink. If it was the same, like example, if I say that E110 or E129 are present in the orange drink, in that case, what we will do? The spots will rise to the same level. So if E110 and E129 both are there, then the spots for orange ring might be 2, and one will match with E110, another one will match with E129. But because they are not present, that's why it will not level up with. So we just have to conclude. And as this, because our main experiment investigation that they did not contain. So we want to show that they are not present in it, and how we can show they are not there. So the height through which the spot of orange ring rise will be different as compared to height of E110 and E129. Yes, Abdullah, Sarfraz.
Say in chromatography there are waves like going up. There are no dots going up.
There are, yeah, actually that's true. But what we consider as them as a spot. Like example, as you can see here, I will show. I got your point. What you mean? You see a streak, like in this case. So there's no actually spot. There's a streak. But what we consider, the region where it is a high intensity, that center part is considered as a spot. So we consider this is a yellow spot. This is a blue spot. You got my point?
Yes, sir.
Okay. Another question. A student, these are exam questions from different past papers, different exams. The main purpose is not like you don't have to memorize them. It's your understanding, to improve your understanding related to the topic. So a student use a paper chromatography to separate a mixture of colored dyes. So there are colored dyes, and student is separating those colored dyes. The diagram shows the apparatus used. So this diagram is showing the apparatus which student use. Draw a line on the diagram to show a level of the solvent. So what we have to do, we have to draw a line to show a level of the solvent, like initial level of the solvent. Initially, the solvent level should be below the origin. So this will be the solvent level initially, but when it will soak up the solvent, the chromatogram, like this should be the original position of the solvent. But when the chromatogram soak up the solvent, it will rise. So we have to show the initial position of the solvent. So how we can represent the initial position of a solvent? So it should always be below the origin. Is it clear? The first part, A1. Then suggest a suitable solvent that could be used. So they're asking for suitable solvent. They did not mention anything that it is insoluble in water. So if in the question they do not mention it is insoluble in water, what you can use water as a suitable solvent. So most of the time water is used as a solvent until unless they specify that it is insoluble in water. Yes, Abdullah Sarfraz.
Sir, what if it is written it's insoluble in the water? What
If
we
it
will
is, if they
write?
mention insoluble in water, then in that case, what should be the suitable solvent? In that case, you will mention alcohol. That's it. If it is water soluble, then you will simply mention water. Then what could be used to put a mixture of a color dyes onto a paper? How we put this color dyes onto a paper? So for this purpose, we use a dropper or a teat pipette. Like maybe you have seen droppers normally used for infants. Like there was a dropper in the previous part. So if you want to add, this is the dropper. So if you want to add a small quantity of a liquid in our drops, so we normally use a dropper for that purpose. Dropper, or it's also known as teat pipette. But you can write one of them, so you can write dropper. The clip hold the paper in position. So the clip is holding the paper in position, as you can see. Why it is important from chromatography experiment? Why it is important that this paper should be clipped? So what is the reason? If the paper was not clipped, then what might happen? That when the paper will soak up, yeah, that's right, the paper will soak in solution, or it will mix with the solution. Yeah, paper will dip in the water. Paper might dip in the water completely, because what happened, as the paper is soaking up the solution, the mass of the paper is increasing, so that will cause the paper to slip. So the main purpose of the clips is to hold the paper at one position, so it does not run, or it does not move, or does not dissolve in or mix in solvent. The another part, the diagram shows a chromatogram uh, obtained for four dyes A, B, C, and D. So this is a chromatogram obtained from four dyes. Give one conclusion that you can draw about dye B. What is dye B? What we can conclude what dye B contain? Dye B is impure. That's two spots are there. That's right. So you can mention it is impure, or contain two different substances, and one of them is D. How we conclude that dye B contain one D? There's anything other is also there, but how we conclude, you can see the position of a D, one of the position of a D matches with B. So it means dye B contain D and anything else. We don't know what else, but there is D is there and another thing is also there. Suggest why a die C remain on the baseline. Why the die C does not rises above the origin, above the baseline. What could be a reason? No, not about pure. When it does not rise with the solvent, it cannot mix with the solution, or it does not dissolve in the solvent. So it is actually insoluble in the solvent used. That's why it does not rise. Instead of mentioning cannot mix with solution, it should you should mention it does not mix with solvent, because when solute and solvent mix, that will make a solution. So solvent does not mix with the solute, so it is insoluble in the solvent. The RF value are used to identify the compound. Calculate the RF value of A. So how you will calculate the RF value of A? You will use your ruler or a scale, measure a distance, move by the spot. You can use the screen, the computer screen right now, and measure these distances. Distance moved by the spot to a distance moved by the solvent. No, if it's not like substance is pure. If a substance is pure, Abdullah, it will rise, but it will give only one spot. If a substance is pure, it will rise and it will give only one spot. So what about the RF value of A? So you will measure 2.5 is for solvent, and about the spot 1.5. So 1.5 divided by 2.5, that will give 0.6. So the answer is 0.6. Yes, Abdullah.
Sir, if a substance is pure, it will go up and it will only remain one spot.
Hmm.
So if we talking about waves, it will
Hmm.
have only one color or two colors.
One color. In terms of color, it will be only one color if it is pure.
So if it's one color, how would we know that it has a point?
No, but what happened when the one color is rising, there will be one part where the color intensity will be much higher as compared to other parts.
So,
So as
but
it
you are
is,
telling that
mhm,
there will be only one color. So how would we identify?
there will be one color, but even the color intensity will be different. When the spot is rising, the intensity of the color will be different. As it rises, one place the color intensity will be higher than the other parts. So we can conclude that it is a pure substance. So either one spot or one color, it means it is pure. Is it clear?
Yes, sir.
Okay. So this is the last part for the class today. Any question related to the class? Question or a doubt?